In this lecture, we will discuss 8085 microprocessor architecture. Now, 8085 microprocessor is a 8-bit microprocessor and it is a 40-pin IC dual in package, DIP IC. Means what? It is a 40-pin 8085. This is an IC. So, one side it is having the 20 pins and another side it is having the 20 pins. This is called the DIP IC. So, and also it is operated on 5 volts power supply. And the maximum frequency of this IC is 3 megahertz frequency. And it is having data lines, how many? 8-bit data lines or 8-bit data bus. Address lines are, address lines are 16-bit address lines. So if the address lines are 16-bit means what? Memory size is how much? Memory size is equal to 2 to the power of 16. That is nothing but a 64 kilobytes memory size. Now these are the few features of 8085 microprocessor. Now here inside this IC, now this is the block diagram. Circuit diagram we are not explaining, only block diagram. If you see, this is the block diagram inside this IC. Now we are going to analyze this each and every block what for we are going to analyze under this lecture. Now here first we will see this is the 8-bit internal data bus. This is the data bus and this data bus is connected to the, so here you can see it is connected to all the blocks and here you can see these are the registers. Now this complete box is registers. Now W and Z, two temporary registers are. Now in bracket 8 is means what? It is a 8-bit register. Now B and C are also two registers, C, D, H, L, 2. Now these are the 8-bit registers. And stack pointer 16-bit register, program counter 16-bit register, increment and decrement address latch is a 16-bit register. Now apart from this, instruction register, the 8-bit register. Now flag register, it is a 8-bit register actually, but in this 8-bit only 5 bits we are using to indicate the flags. Again, arithmetic and logical unit, it is not register actually. So arithmetic and logical unit. And accumulator is a 8-bit register. Temp register is one more temp register is there. Now here W and Z are the temp registers and one more temp register is for the 8-bit register. Now these are the few registers are there. Now first we will discuss about these registers. Now already we have seen the block diagram, right? Block diagram of microprocessor or CPU. It consisting of what? It consisting of ALU, control unit and registers. Now here you can see the ALU. This is the ALU and this is the timing and control unit. Control unit. This is the control unit. And registers means what? These are all the registers. We are going to study these registers now in this lecture. Now here you can see general purpose register and special purpose register. Now few registers we are using for the general purpose means what? To hold the data. Now those are B register, C, D, E, H, L. Individually, these are all 8-bit register. Now pairing, by pairing BE together, we can use as a BE as a pair and DE as a pair and HL as a pair. As a pair, we can use it as a 16-bit registers. Now you can't pair B and E here. Only BC as a pair you can use, DE as a pair and HL as a pair. Now these are the general purpose register which we use to store the data. Now coming to the special purpose register, now in this accumulator, this also we can indicate it as a register A. So this is a 8-bit register. This is a part of ALU, you can say it as a. Now here if you see, for the ALU, one is connected to the accumulator and another one is connected to the temp register. So accumulator, you can call it as a part of the ALU and which holds the data for the arithmetic and logical operations. Now to do any arithmetical and logical operations, one of the operand must be in the ALU. If you see here, two operands we are sending to the ALU means what? One of the operand must be in the accumulator, one more operand will be in the temp register. Or if we are storing in any one of the register, that will be moved into the temp register. So that will explain at the time of internal operation. Now, if only one operand, if we are performing any logical and arithmetic operations on only one operand, and that operand must be moved into the accumulator. Now, after completing the process, result also again stored into the accumulator in the 8085. In the 8085, result will be stored only in the accumulator. And after that, if we wanted to move into the some other register, or if we wanted to move into the memory, that can be we can do later. But after completing the arithmetic and logical operations, immediately result will be stored in the accumulator only. Now coming to the program counter. Now if this is your program, we have to write this program in a specific address location. Now this address will be held by the program counter whenever we are executing this program. So next executable instruction address will be held by the or pointed by the program counter. So here in the 8085 address lines are how many address lines? 16-bit address lines. That's why this program counter size is 16-bit. So it is holding the address of the next executable instruction. Now coming to the stack pointer. Now part of the memory locations we are using it as a stack for the processing purpose. Now top of the if this is a top of the stack, then this is top we will be held by the stack pointer. So stack pointer hold the address of the top of the stack. Again, it is holding the address. That's why it is also 16-bit register. Now, next again flag register. It is a 8-bit register. Flag register will indicates the status of the accumulator. Now, after executing the instruction, result is stored in the accumulator. Then what is the status of this accumulator? That will be indicated by the flag register. Now, that flag register in detail information I will explain after completing this register. Now, these are the 4 register which are accessed by the user. Now coming to the 4 more register which are not accessed by the user, but it is accessed by the processor. Now instruction register. Now after fetching the opcode from the memory, that opcode will be stored into the instruction register. Now if the opcode is fetched from the memory, that opcode is loaded into the instruction register, and after that it will be decoded. So that is the instruction register, and it is opcode size is only 8-bit. That's why it is a 8-bit register. Now coming to the temporary register W and Z. Now here you can see the W and here W and Z. These two are the temporary register. These two registers are used by the processor inside. Now if we wanted to exchange the DE register content from with the HL register content. Now for that we have one instruction XCHG. This is nothing but what? Exchange. Exchange means what? It will exchange the content of DE to the HL pair. So 16-bit the content will be exchanged with the HL register pair. So for that what? Directly this HL content if we placed into the DE, then the already existing content will be replaced. So for that what? Microprocessor will store any one of the register. Now DE register pair or HL register pair content into the WZ, and after that, now for example, HL register content is moved into the WZ, then the DE will be moved into the HL, and after that WZ will be moved into the DE. Like that, it will perform the XCHG. For now such instructions, to execute such instructions, microprocessor need internally few register. Those are the W and Z. These are the temporary registers which will use when now W is a 8-bit register, Z is a 8-bit register. Both combined together it is a 16-bit register. Now increment and decrement, it is a 16-bit register. Now here if you see the program counter, after fetching the opcode from the memory, immediately program counter will be incremented automatically and it will point the next executable instruction. So here program counter automatically increments. That automatic increment can be done by the increment decrement register. Now coming to the stack pointer. Stack pointer always hold the top of the stack address. So if we are using the push and pop operations, at the time these address locations should be incremented and decremented depending upon the instructions used. So for that purpose, this increment and decrement register will take care of that. So automatic increment and decrement can be done by using this register. And address latch means what? It will hold the address. At the time of increment and decrement, it will hold the address of the program counter or stack pointer, and it will increment and decrement. Otherwise, whenever the microprocessor sends the address to the microprocessor, that time that address will be held by the address latch register. Now this is about the different registers in the 8085. Now we will see the flag register. Now flag register is a 8-bit register. Here you can see the 8-bit register D0 to D7. In this bit number 5, bit number 3 and bit number 1, bit number 3, bit number 5 are not used. Means what, here if it is a 0 or it is a 1, so these are not indicating to any flag. So now coming to the bit number 0, it is showing the carry flag. Now if I take one number, that is nothing but a FE, if I have taken, if I am adding with the bit 2, means what, 0 2, if I am adding with the 0 2, then what is the result of this F? How can I write? I can write F as a 1 1 1 1, and E I can write it as a 1 1 1 0. The B equivalent BCD value we have to write. Now 0 we have to write it as a 0 0 0, and 2 we can write it as a 0 0 1 0. Now if you add this, so what are the, now in the last B basic electronics I explained the additive properties. So if you add 0 0 you will get 0. If you add 1 1 then you will get some 0 carry 1. And if you add these two, again you will get 0 and 1. Now like that, if you add these bits, now you will get this is the result. So last one also you will get one carry, and your result is this. So accumulator holds the 00H value. This this equivalent hexadecimal value is 0, and for this equivalent hexadecimal value is 0. Accumulator is holding the 00 value, but the actual result is what, 100, 100. But this 1 is the carry. This carry is indicated by the flag register. One of the flag, carry flag, will indicate this carry. So along with the accumulator, if we consider the flags, then only our result will be proper. Otherwise, instead of showing the 100, it will show the 00. So this is not the correct answer. Our answer is 100. So for that, what we have to consider the carry flag. That carry flag is indicated by the flag register. Now, whenever the carry is generated from the 8th bit, now most significant bit. Now, if this is a A0, if I consider, this is last one is a A7. From the A7, if any carry is generated from the most significant bit, if any carry is generated, then carry flag will set. Otherwise, it will reset. Now, coming to the parity. Now, if this is the accumulator, if in this, if any number of even number of ones are there, then at the time parity flag will set. Otherwise, it will reset. Now, if our result is 1 0 0 1 0 0 0 0, then here how many number of ones are there? Even number, 2 ones are there. So even number of ones are means what? Parity flag will set. Now coming to the auxiliary carry. Now this complete FE is nothing but what? E is a lower nibble and F is a higher nibble. Nibble is nothing but what? 4 bits together we call it as a nibble. So here this is a lower nibble and this is a higher nibble. Now when we are doing the addition, if any carry generates from the lower nibble to the higher nibble, or from the third bit to the fourth bit. Now this we can call it as a 0 bit, 1 bit, 2 bit, 3 bit. This is the fourth bit. From third bit to fourth bit, if any carry generates, then the auxiliary carry will set. Otherwise, you can say it as a from the lower nibble to the higher nibble, any carry generates, then the carry flag will set. Otherwise, it will reset. Now coming to the 0. If accumulator value is all the accumulator bits are 0, then the 0 flag will set. Otherwise, it will reset. Now in this example, accumulator is holding all zeros. That time 0 flag will set. Otherwise, it will reset. Now coming to the sign flag. MSB bit. Now in the accumulator, most significant bit, nothing but what, this one. Most significant bit is 1, then the sign flag sets. Otherwise, it will reset. So setting most significant bit is 1 means what? The answer is negative. It indicates the negative. So sign flag gives the information about our result is negative or positive. So this is about the flag register. Now the remaining blocks like interrupts, serial IO, and timing and control, these we will discuss in the next lecture. Now here with this we will end the 8085 microprocessor registers.